I'll go ahead and just kind of introduce myself a little bit while our technology is sorting itself out here. My name, for those of you who I have not had the pleasure to meet, is Don Tipping, and I've been farming over there in the Applegate Valley for the last 20 years. And had the good fortune of knowing Chris Jagger and his family for the last number of years, just over the hill from us. And I'm grateful to be here amongst a lot of people who like to grow things and are, for me, I feel like I got into this whole way of life, so to speak. It's not so much, farming isn't a job, it's a way of life, really, because I like to be outside and working with plants and the soil and the sun and water, and it's really kind of like a dream come true in a lot of ways. Anybody here ever read the Small Farmers Journal? It's probably my favorite publication. It's produced out of Sisters, Oregon, which is over there near Bend on the east side. And Lynn Miller is the man who edits that. It's a kind of a tabloid size magazine all about horse farming with draft horses. And what's really cool, why I bring this up, and why I really want to encourage us all to really start off this next session from a place of gratitude, is in this Small Farmers Journal, he publishes all the letters to the editor that they get. And I would say about 80% of them are people who, they're wherever, in the Midwest or, somewhere in the middle of the country. And there's, and they say in their letters, well, I'm 60-something years old and I've been working a job for a lot of years, saving up money to hopefully someday achieve my dream of getting my own small farm and growing my own food. And so those of us that have already been enabled through whatever, gifts, miracles to already be on land in some way, even if it's the way your land tenure is in a way where you're not sure in terms of the ownership, is just let that sink in. Just the gratitude to be able to be on land, working with the the natural elements of creation, is something that is truly a great gift. And I think when we approach what we do from that perspective, then it helps whatever we do and whatever we have to surmount as people that are tending the earth to do it with grace and humility. So my farm over there in Williams, we have over the years gone through a lot of different incarnations in terms of our approach to what it is we grow. Just a kind of quick snapshot. We've grown, produce for restaurants, produce for different, natural food stores like the Ashland Co-op, done all the farmers markets in the area. We've grown seed crops. We've grown medicinal herb crops for the herb farm and Pacific Botanicals and Wild Botanicals. And now we have our own seed company. So what I'm hoping to take us on today is a bit of a journey around the evolution of, our relationship that any of us will have with what it is we do, what our livelihood is. So I want to orient us to where we are. And I think when we're dealing with plants and the soil and the incredible diversity of life that our lives are dependent upon, it's really easy to overlook the vast complexity of what's taking place on, in, around us, whether we pay attention to it or not. So, with our farm now, we really focus a lot on seed. So I'm having to learn a lot about pollination, all of the insect allies, the prevailing wind patterns, genetics, this whole much wider sphere of nature than I ever paid attention to when, let's say, I was just bunching radishes to sell to the Ashland Co-op. So if we think back here, we're here in the Milky Way galaxy. When you look up at night, you can only see about 4,000 stars. So if we were to look at this disk of the Milky Way galaxy, imagine if I were to take a quarter and glue it up on there. That's about how many stars you can see at night. We have just a tiny little glimpse into the complexity of what makes everything around us possible. So I think it's really necessary to start from that place and somehow let that sink in, because that's what's going on. And from that perspective too, consider we're moving 11 billion miles a year on our Earth. So even though we think we're going in a circle, we're actually moving in this giant corkscrew. This is a relative scale image of what the moon would look like if we could see it against the Andromeda galaxy, but the Milky Way galaxy is so bright, those 4,000 stars we can see at night if you don't live in a city, that Andromeda is just a dim background glow. And as I referred to this kind of corkscrew spiral that's 11 billion miles long, that's dragging us along through the galaxy, through the universe, functions in this spiral, that there's some form, there's some rhythm, there's a periodicity to it. And we see this everywhere. This is an image of one of Jupiter's moons, and we can see those same kind of spirals there. So what I want to bring our attention to today is the grand kind of time spiral of the evolutionary history of reproductive biology. Does anybody, when I say that, are people like, what in the hell is that person talking about? Okay, well this is really important to understand. How do we get to where we are now? We didn't just get plopped down. We're part of a continuum that has been occurring for a long time. As far as the estimates go, it's about 4 billion years here on Earth. Our solar system, about 14 billion years, and the most knowledgeable particle physicists just came around to the conclusion that we had this notion that the universe had a date, and they're like, that's not true. It's been happening forever. So, which is cool, because that's, as kids, we all were introduced to that idea of infinity, and it probably boggled a lot of our minds, but over time we come to peace with that there's just some things that don't have a finite limit to it. So, the idea that the universe is infinite is really kind of cool, because I think it harmonizes with that childhood wonder about things that we can't put in a container. So, the first life on the planet, we're constantly figuring out new things, were microfossils, about 3.7 billion years old. So the Earth basically was still cooling down, if you will. It was still, densifying. So 3.7 billion years is a really long time ago. And these were monocellular. They were what are known as prokaryotes. Who in the room, if somebody were to ask you, what's a prokaryote? You'd be able to tell them. Raise your hand. All right. Okay. You all have your first homework assignment. If you have the ability of writing this down, go figure this out, because it's really important to understand, because our entire microflora inside our body and inside the soil is made possible because of prokaryotes. These are single cellular organisms that do not have a nucleus. They're the basic building blocks of life, and they rocked it here on planet Earth for 2 billion years, from 3.7 all the way up to 1.7 billion years ago. It was really darn simple. So, and then for those of you that are remember some Latin, prokaryote means before. Pro is before, carry is nut. Before the nut had a shell. Does that make sense? So you can think of a nut with just the shell and nothing in it. That's what will help you remember the Latin word for an organism that has no nucleus. So, life cruised along like this for a really long time. Things just floating around in the ocean, in a warm ocean full of minerals, absorbing nutrients. So when you think about, people have made reference to compost teas, and you're working with bacteria, you're working with largely prokaryotes, and then something happened, and we're not quite sure. It was probably involved lightning and amino acids. Eukaryotes, those organisms that were after the nut had a shell. And so everything we can see that's alive without a microscope is a eukaryote. When you ask somebody, what's a living thing? Probably most people will begin to rattle off eukaryotes. It's all plants, all animals, and all fungi. But what's interesting, if we go back to what happened here, at some point there was, I'll get to the lightning. There was something happened, and these prokaryotes, my hunch is that they began to consume one another. They recognized that some kind of collaborative working together would enable more life to happen. But there wasn't a realization or anything. We're talking about pre-nucleic organisms. They're really darn simple. So, but this first crossroads in life on planet Earth, and it's probably occurred the same on other planets as well, was to the protists and the algae. So the protists were the progenitor of all animals. So everybody remembers like those little images of bacteria where they have the phyli, F-I-L-I, that help them move around through the soup. Those were the first protists. These were the bacteria that could actually like move around. I'm like, I'm going over there. And the very first ones that worked with chloroplasts were algae. So in this, they could somehow interact with the sun. The source of this incredible spectrum of photons to harness energy. And basically all life functions in this way that it's like a battery. It uses infrared light from the sun along with other ranges of the spectrum, along with water. You need those two things, and you got everything, the sun and water. And then, miracles really began to happen. And we went to this incredible flowering of biodiversity. So anybody in here ever eat seaweed, sea vegetables, nori, sushi? So you've actually eaten, way, way, way back. Algae is not a plant. It's a progenitor of all plants. They were the very first things like cyanobacteria, blue-green algae that could somehow interact with the sun and chloroplasts to create sugars and create energy. And then from that point, then we've had kind of this mushrooming effect from the eukaryotes. We had the early plants that moved on land, like the cycads. Here's a good image that makes us think of that, this kind of early Earth that was cooling down, where probably the early life was just clustered around undersea volcanic vents. And it required all those minerals because they couldn't go out and get it. They had to just absorb it. These, very, very simple plants. These, cyanobacteria, things of this nature. And then eventually, by the time they got on Earth, our atmosphere was still so thick and dense. This kind of, Venusian type atmosphere, where we had cycads and the giant horsetails. If we go back, I think it's 300 million years ago, Paul Stamets was who related this to me originally. They found these fossilized, they thought there were trees that fell down in Mexico, and they realized they were about 30 feet tall, but they were actually mushrooms. And at that time on Earth, those were the tallest living organisms. A lot of the really big dinosaurs didn't happen till way later. So when we go back 300 years, there were no flowering plants. Plants were like ferns, and they reproduced with spores. Anybody ever turn a fern over and see those, what are called sori on the back? And it's kind of this very primitive, or horsetail. People familiar with horsetail? If you're not, you should get familiar with it, because it's a really important source of the kind of minerals that the gentleman presenting a moment ago, in the biodynamic farming approach, we use horsetail as a source of silica along with other minerals. Anyhow, horsetails is a super ancient plant. So, these things kind of crept on land and took a long time to develop. The very first plants were these largely dioecious, where you have male plants and female plants, gymnosperms. So the conifers, things of this nature. We can think of ginkgo is actually a conifer. So gymnosperm means, in Latin, a naked seed. Sperm being the seed, gymno meaning naked. And then later we get to angiosperm, which is fleshy covered seed. A really interesting here, because we're in the Northwest, if you ever have occasion to be walking through a forest where there are Pacific yew trees. Anybody familiar with that plant? Really awesome wood it was used for bows by the indigenous people all throughout the Northwest. But it makes what looks like a small berry, and in fact it's not. It's a conifer, and if you look up in it, it looks like a little huckleberry, and then you can see the seed just kind of sitting in there. It's not encased. So that's a really helpful way to perceive what gymnosperms are, because you can see the seed right there. And those are edible. Just don't eat the seed, because you might not live to tell about it. But the fruit themselves taste like a gummy bear, if you will, kind of like a jelly-ish gum. They're really good. Anyhow, so we moved from dioecious gymnosperms to monoecious gymnosperms. Eventually, the plants figure out how to have male and female flowers on the same plant. So that would be imperfect flowers. A great example is a pine tree. Anybody ever park their car under a ponderosa pine tree, and it's covered in that that dusty pollen. So those are not coming from the pine cones. That's the female flower. The pine cone is the female flower. The male pine flowers, if you will, they're kind of these purple things. And incidentally, pine pollen is an excellent source of high protein nutrition that folks in the primitive skills community for a long time have eaten. To put some of this in perspective, I'm going to back up just a moment. So we were talking about 300 million years ago. 200 million years ago, the Atlantic Ocean did not exist. So we're talking like, that's like yesterday in a geological time scale. And at that point, still, there were no gymnosperms. Mammals were like almost non-existent. There were maybe a couple like voles that were hiding out from everything else. Life was very simple. And 120 million years ago was a major threshold occurrence on the planet because it was the first flowers that interacted with insects, the first angiosperms. So think about this for a minute. Like, all life at that point relied on itself to reproduce. Like, you know, like humans. We don't need another species to reproduce. And then all of a sudden, the angiosperms come along, and there's this incredible flowering. And I'm just going to kind of cruise through some of these to get to some plants of all of the different combinations. It would be like, let's say we're kids, and you were given like, so 300 million years ago, if you were a kid, you had like 8 Legos, and you had to figure out what to make out of 8 Legos. And then 200 million years ago, you've got like 50, and you can do some more stuff. And then 120 million years ago, it would be like your big brother, your big sister, your cousin or something just kicked down their whole Lego stash. And all of a sudden, you have like 8,000 Legos. And nature was just, you know, it was a huge party at that point. And if we go back to what was going on at that time on the Earth, and why this is important is this is where all our soils came from. This is where all the organisms that we interact for everything in our life with came from. And back 120 million years ago, there were dragonflies that were 30 inches across. You know, there were things that just totally boggle our imagination because the atmosphere would support it. And then this important occurrence of the insect realm became crucial to the reproduction of many of the flowering plants on the planet. So then we have, you know, so we went from, you know, dioecious gymnosperms to monoecious gymnosperms. Then we have dioecious angiosperms, and then we had, eventually it evolved to monoecious, meaning you have both male and female flowers on the same plant. That are angiosperms that require, you know, some type of cross-pollination. And then again, wind was the initial means for how cross-pollination occurred. It's a very primitive reproductive strategy employed by plants. Usually when there's wind-pollinated plants, it's an indicator they've been around for a long time, probably predating insects, or at least the pollinator variants of insects. So, you know, as it kept marching along, and I've had conversations with somebody in here that was that cannabis most likely was initially a monoecious plant that had male and female flowers on the same plant, and it was human intervention that pushed it to become dioecious, meaning separate female plants and male plants. So that's just an interesting aside there of how we can interact with nature. But when we think about, you know, how all these different reproductive strategies have allowed plants to move into all these different niches. And as nature became more and more diverse, so go back to that, the Atlantic Ocean, that rift opening up between, you know, Pangaea and that area opening up. If you go outside and you pick up a native rock around here, this area, the Klamath-Siskiyou, it's older than that. So a piece of granite from around here, a rock on your place or something, it's actually older than the Atlantic Ocean. So another thing to understand that in those rocks oftentimes are being chelated by lichens, and that's what's creating your soils and your minerals and all of the, you know, different acids and enzymes that are working on all that stuff have been around here for a long time. So why this is important is we will be well served to, you know, be harmonious with all these forces and be symbiotic with the way that nature has co-evolved with this environment, with the minerals, with the atmosphere, with the, you know, the flora and fauna that was here or wherever you are. And once you begin to interact with this, it's sort of like, who can come up with ideas like this if you've never seen one before, and be able to, like, every single time you do it a little bit different. And that's what nature is doing as we think about this evolution of the way reproductive biology works. I'm going to jump from plants over to mammals for a minute. Here in North America, we have 1,000 different species of bats. Like, let that sink in for a minute. Like, who here's seen a bat flying around? Okay, how many species of deer are there in North America? 3. There are 1,000 species of bats. Why is that so? That's a really unique niche. Like, mammals that fly around at night and use sonar. Like, you're the only one. So the first one that crossed over that threshold, that event horizon, was like, woohoo! Like, there's a lot of potential here. Whereas deer is like, well, the moose are over there, and the elk are over there, and the pronghorn antelope are over there. They're like, that niche is kind of full. There's a lot of things that eat grass. But things that can fly around in the pitch black and eat 5,000 mosquitoes a night per bat, that's a cool niche. Or ones that evolve to, consume nectar, or that, pollinate some unique thing. Or ones that are even, I guess, parasitic in a way, like the blood-feeding ones. So I'm mentioning this just to let the diversity of the natural forces that we're constantly interacting with, and every single breath that we take is inextricably linked to. And, as that evolution kept going on, here in North America, the most diverse plant family is the Asteraceae, formerly known as the Compositaceae. And for those of you that have learned botany or are in the process of learning botany, it's all going to be changing because of DNA analysis, and we're able to peer a little deeper into what the story actually is. We're kind of, through molecular biology, we're being given all the notes that the botanists of old never had to be able to determine what is going on with these plants. But I don't want to kind of throw out some of that, the complexity to be hurdles to anyone for cultivating a deeper understanding to what's going on, because ultimately all of life is following the same pattern of how can we creatively evolve into and address niches in the most efficient way possible. So here's a Mizuna plant. These are dragon's blood trees. Notice the similarity here. Here's a yew tree. Here's a banyan tree. Here's people in Bangladesh that figured out how to grow bridges through hollow logs using aerial roots. It's another image. Here's somebody with a computer simulating that whole same thing. Here's the way sand dunes form. This is the way wind interacts with things. The way different plants are responding to the most efficient way to grow seeds, attract pollinators, hold a structure, gather pollen from other sources or disseminate pollen. So when we think about, like, what was the most efficient means for reproductive biology here in North America is Asteraceae. It's, by far, there's more species in that plant family than any other. So those are the daisies, the sunflowers. This is a gaillardia, also known as blanket flower. It's like a Great Basin wildflower. And the Asteraceae, by and large, are perfect flowers. They have both male and female flower parts in the same flower, and oftentimes they're self-pollinated. So they don't even need another individual to create seeds. They can receive their own pollen. So that's a really unique thing, whereas plants like corn or any of the outcrossers require pollen from another individual in order to make seed. And plants like broccoli, Brassica oleracea, which would also be Brussels sprouts, cauliflower, cabbage, kohlrabi, lacinato kale, they won't even receive pollen from they have male and female flower parts on the same plant, but they are self-incompatible. They actually, it necessitates that you have multiple individuals. And actually, to maintain the genetic breadth for the population, to keep all of the, has everybody heard of epigenetics in this room? Or, junk DNA? This is this new field that's emerging Who here has heard of, quantum physics? Okay, probably most people. There's a new field called quantum biology. So in quantum physics, we're kind of deconstructing and we're like, well, those used to be the rules, but we keep finding out that those rules don't work over here, or there's a new rule that applies under these situations. So in biology, it's the rules. This is that, that's that. You can't do this. It's the school of reductionist thought. Quantum biology is the school of like, well, it depends. In the presence of this stress or in this environment, or like the one fellow was showing the dried peppers, and when you have good minerals and all of a sudden it's perhaps not decomposing at the same rate. So quantum biology is the realm of imagination, and so this is a great invitation for us into collaboration with nature, and that our imagination and our creativity will help influence the potential of what plants and the soil can do. What's the largest plant family on planet Earth? Anyone? I haven't heard it yet. Orchids, the Orchidaceae. By and large, there's more species of orchids in Colombia than there are species of plants in California. So think about that in terms of imagination and just the incredible brilliance of how Mother Nature was like, whoa, we found a cool niche here. We're going to rock this one. And it's going to be, just totally wild. And they're even in the direction of things like vanilla. So I share some of these things, too, to encourage us all that we were all, steeped in a culture of reductionist linear thinking, of boxes, of quantification, of breaking things down into their constituents. And one of the forefathers of agricultural chemistry was Justus von Liebig, Liebig. Wasn't that an interesting irony there, his name? So anyhow, he developed what's called the Liebig's barrel. So at that time, back in the 1800s, when he was working on all this stuff, everybody used barrels that were made by a cooper, like a wine barrel kind of thing. So each plank represented a mineral. So what Liebig did is he took plants and he burned them down and analyzed the ash and said, oh, wow, plants are pretty much mostly water, carbon, phosphorus, nitrogen, and potassium, and a little bit of calcium and other stuff. So what if we could supply those nutrients, and then we would get away from how messy farming is, like animals. And at that time, if you had a farm, about 3/4 of your farm was to raise animals, to till your fields and the fertility for doing the other part of your farm that actually made your food and possibly a livelihood. And that's how farms were until World War II. And this awareness around Liebig's barrel is what drove the war industry, when they didn't have a war to fight, to a war on the soil and the war on the earth. And we saw this really get going after World War I. And so tanks, instead of being used for war, became tractors. And then all of a sudden we didn't have the draft horses. We didn't need the draft horses and the oxens and the mules and that whole culture that went along with that. That was really awesome. If we go back, all of our great-grandparents, somewhere back in there, this room would probably be full of ancestors that were involved in that type of life. Poison nerve gas became insecticides and pesticides and fungicides, that whole industry. And also the bomb making, that amazing thrust of industrial might to make bombs. When they didn't need to make bombs anymore, what did they do? Fertilizer, yeah. So what's the most important invention that's ever happened here on the planet Earth? Hey, do you hear me talk before or something? Okay, awesome, dude. Like, raise your hand. That's like, I've been using this story for like over 10 years. You're the first person to ever answer it correctly. I'll repeat it. Yeah, this dude, smart person. The Haber-Bosch process. Anybody ever have a German car, B-O-S-C-H, when you buy parts, Bosch or power tools, they make, it's the same, industrial lineage that goes way back. Basically, these two scientists figured out that, okay, there's all this nitrogen in the air. Why can't we get it into the soil? Well, nitrogen-fixing plants can do this. Lichens also, if you like usnea, old man's beard, different things like that, those are nitrogen-fixing and a very rich source of nitrogen, in fact. What are the other two sources of naturally occurring nitrogen on the planet? Yeah, and also manure, obviously, but that's because of bacteria as well. So the three natural sources of nitrogen, just to repeat them, were lightning, nitrogen-fixing plants, and bacteria and manure. They're kind of, bacteria are basically animals. So with the Haber-Bosch process, they figured out that if you had an energy source great enough, you could basically crack the bonds that hold our air together, and that nitrogen would precipitate out. So, remember that image of the oil wells from like the 1800s, and that classic like Texas tea, black gold, with the flames on top? That was they were burning off the natural gas because they didn't know what to do with it. Because we didn't have a use for it, it was unstable, it was dangerous, so we just burned it off, and we just wanted the oil. Well, the Haber-Bosch process, they were like, They figured out, like, what if we could use that natural gas to break the bonds in our atmosphere to, get anhydrous, ammonia, nitrogen fertilizer. So what's amazing about this process is that we've doubled the amount of nitrogen applied to the earth, or just in circulation, if you will, of all those other sources combined. So we apply as much nitrogen fertilizer to the Earth's surface as all lightning, because what lightning does is it's basically like a huge source of energy from the sky that like fractures, nitrogen, and then it rains down. And that's why if any of us have like seen the weavings or the artwork of the Southwest, or the Navajo, Dene, Hopi, Apache people down there, that the thunder gods, there were these, because they knew that those thunderstorms brought fertility. So a thunderstorm rain is actually raining down a trace amount of nitrogen. So once again, we're applying as much nitrogen as all lightning, all animal manures, all nitrogen-fixing plants, and all bacterial interactions. That's huge. The human population before the Haber-Bosch process was 1.2 billion people. So that other 6 billion people have been made possible because of the Haber-Bosch process. And without that, now that we're seeing all this natural gas go to power plants, clean burning buses, fracking, all that stuff, that spells really bad news for the fertilizer industry because natural gas prices are going up. So the reason I bring this up isn't to get into a whole scare thing, but this is what motivated Rudolf Steiner to develop biodynamic farming. Because basically these farmers in Austria and Germany and Poland, that region of Europe, began to notice things like, whoa, it's not working the way it used to. We used to just like till the fields with the moon cycle and go out there with the cows and the horses and plant and sing the songs and do the dances, and everything just grew like crazy, and then all of a sudden it stopped working like that. And not just like the fertility, at that time on the planet, a lot of people's, we're talking like early 1900s, were making their roofs out of thatch. And they noticed that they needed to redo their thatching more frequently because the silica content, the mineral content of the straw was no longer what it once was. There were more incidences of disease and pests in their animals and their plants. So it's sort of like, and I think it works this way when we go back. I'm just going to fly through some of my images because I got on a tangent here. Just because your neighbor's doing a farming practice that you don't agree with doesn't mean it doesn't affect you. And we're seeing this more and more with pollen drift and pesticide drift. But basically what Rudolf Steiner was aware of is that when that whole shift around World War I occurred, that it actually affected the fertility and the way nature functioned for the whole planet. And that now, we kind of like, our job just got a lot bigger in terms of it's not just about you and your crops and like your family. It's sort of like, oh, the whole of nature actually requires the active participation of humanity. Because we're just another part of it. We're not distinct or really all that unique. We still breathe, we still need water, we still need food, and we still decompose. So, and we go back to the biodynamic understanding, a lot of what was presented earlier, this is things that used to just occur naturally, and now we kind of need to jump into the driver's seat and make sure that we're covering all of that diversity that is normally we call that just under the broad heading of ecosystem services. You know, like everything's out there just doing it. You know, and as I'm passing by some images of animals here, Ernfried Pfeiffer, who is a protege of Rudolf Steiner, some great books by Pfeiffer. If you want to dive into this, it's way more approachable than Rudolf Steiner. Don't start with Rudolf Steiner reading this stuff. He asked once, well, I'm going to share two little stories that he brought up. One was, and this is a really foundational one. I'll take a breath here. He asked Steiner once, like, okay, if humanity can be like a Buddha or a Jesus Christ or a Muhammad, like a total, or a Amaji or a Dalai Lama, like of that potential, you know, of that level of compassion and kindness and all that, why don't we see more of that? You know, if everybody has that potential. And Steiner's answer was kind of interesting, that it was a problem of nutrition, that unless the body received adequate nutrition, the soul would not have the, you know, the power to free itself from the, you know, the burdens of gravity in the body. So, you know, in terms of like, what are you putting into what you're putting out there? I think that's the basic understanding. So, and as we look to our kinship with all of the other elements of a natural system, of a whole system approach, and biodynamics is really just one permutation of a whole systems approach to agriculture. You know, natural farming or permaculture would be other ones. Pfeiffer was also asked, like, hey, I live in a city, I can't have cows. My neighbor doesn't like chickens or the roosters. And what's going to be my animals? He said, frogs. The residue that frogs have on them makes things grow. The sound frogs put out makes things grow. And if you think like, oh, this guy's out there, you know, I don't believe that. Anybody here read the book Secrets of the Soil by Christopher Tompkins? Yeah, amazing. Go check it out. Very accessible. Lots of little anecdotal stories, some about biodynamics, but one of them was a citrus orchard in Florida where the yields were going down, neighbors were doing you know, chemical-based farming, and the birds didn't come around anymore. So they just started broadcasting the sound of the native birds, and all of a sudden the yields went up. You know, little things like that. Like we don't, just because we don't understand it doesn't mean it doesn't work that way. You know, like who here is like popped in an aspirin or an Advil or something? Do you actually know what it's doing in your body? Like, does anyone here actually know that? Yeah, you do it. You trust that it's going to make the headache go away. So same with a lot of these practices. There's a certain, like, nature just has it figured out. You know, like a couple friends are musicians around here, and we've noticed, like, people in America, we can dance really well to a 4/4 rhythm, maybe a 3/4, maybe a 6/8. As soon as you go into some weird polyrhythm, people stop dancing. They don't know how to dance like that. There's certain, you know, like foundational recipes that help us find rhythm. And the soil and the way all of the microorganisms work is that way. You know, and so that's one of the things that's been cool for me. I've been practicing biodynamics for 23 years or so now on my farm, and, you know, making some of the preparations and applying them and watching over time. And it kind of hit me once. I'm like, oh, it's not even actually about this thing or this recipe or following this equation. It's actually just get out there and pay attention. Walk around your fields. Walk, you know, with no actual function, you know. And there's that old saying, like, the best fertilizer is the gardener's own shadow. And I wish I remember, there's one in Spanish that's the best irrigation is the sweat from the brow of the farmer. But, you know, so what that's telling us on a much deeper level is that it's about the interaction and the participation. And I've been really challenged recently how to, in a kind way, have a discourse with my more urban friends that are trumping up the idea of these vertically integrated modern farms that use like LED grow lights, and it's sort of like, well, that's cool. I'm glad you're, you know, like want to be engaged in growing things. But the reality is we have this thing called the sun, and it's like free and really happening, and it provides, you know, all these photons that you're never going to come up with a light bulb that does all that. I'm sorry. And also our eyes, there's an amazing book for anybody writing things down. There's a man, Gerard Pollack, And he just wrote this book recently. He's a scientist at University of Washington called the fourth phase of water. So we know how matter can form as Tonka trucks. It can form as, no, I'm sorry. It can form as a liquid, a gas, or a solid. There's actually a fourth phase that water is capable of occupying. And I'll bore you with the technical specifications of it, but basically it's a charge-separated phase where there's somehow when it interacts with a solid object, the negative ions and the positive ions separate, and charge separation is a source of energy. So basically, just the water on the planet is enough energy to power everything forever if we just figured it out. Because look what's happening in nature. So basically, our eyes have infrared receptors. Can we see infrared light? No. Why do we have receptors for it? Because we came from all those like protists and prokaryotes and all those things that used water and light from the sun to live. So we're not that different than all that stuff. And kind of along those same lines, there's a fellow named Ryan Drum who's an expert on seaweed, and people ask, like, after Fukushima, can we afford to eat seaweed? And he says, can you afford not to? Those minerals that are in the ocean and, accessing that whole amazing sphere that covers most of our planet. So back to Gerard Pollack, is this understanding that infrared light and this charge separation in water is what drives all metabolic processes in all life. Like, let that sink in for a minute. The other scientists who've come forward with this information have been killed or discredited. He had his work peer-reviewed and published by 10 other sources so he could put out this book. It's being called the most important scientific discovery in the last 100 years. But it's so far over most of our heads, including myself, that we don't really know how to apply this. But I'm beginning to kind of see, it was like, oh, that's what's up with biodynamics. That's what's up with your compost tea, agitating it, getting more oxygen in there and getting more activity between all of these positively and negatively charged ions in water. That's where the magic is. And so, I just encourage us all, like, there's figuring stuff out, but as soon as you like figure out something, then 10 more questions arise. So, and that's where I think just staying in this place of open observation of like, well, there's that saying, what would Jesus do? It's sort of like, well, what would nature do? And nature can come up with a gazillion different solutions of how to attract in seed dispersal. And that's what we're looking at here in these images, including humans. Maybe that's our most important function, actually. And just observe, like, what are the creative solutions that occur without our awareness? This is a mulberry tree and a cat that just hung on the top of the ladder, like easy pickings. How do our watersheds work? How does natural water catchment and slow release of all, like, so we had all this rain all over the Northwest. Guess how many people are going to be bitching about drought come late August? A lot. What do you mean? Like, so my friend Penny Livingston, she's a permaculture teacher down in the Bay Area. She says, we don't have a water shortage problem. We have a storage shortage problem. Like, it's just kind of turn it around in a Zen koan way, a lot of the issues that we're addressing. And, I've been really fortunate to be able to do plant breeding in my life, and that's what I'm really getting into. So a part of the process through doing that is you have to learn what that landscape is. So let's say, like, we're doing a melon trial this year. Like, I have my favorite melons, musk melons, cantaloupe type things. But our climate's different than whenever I developed those favorites back years ago. I may have prejudices that are based on old information. Same, like, I was talking with my older son. He's like, you never let me play my music. And I'm like, well, I don't like it. And he's like, well, how will you ever know if you don't listen to it? And we're like, you're probably right. Okay, So, like, we do trials where the main, just like that walking through your fields where your main objective is gratitude and also observation. So doing an observation trial where you grow, like, we're going to grow probably 40 or 50 different varieties of melons. And even though I have a seed company that doesn't sell any F1 hybrids, You bet I'm going to go buy all the best hybrid melons out there, because how do I know what we're selling is any good unless I look at it next to it and then taste it? And then also, do you think I'm going to be putting row covers over this to protect it from pests? No. I want to know what actually works. What works here? You can make a lot of things work with a lot of, tent poles propping it up all over the place. But long term, as we really have to figure out a society, a civilization, because clearly our leaders aren't doing that unless perhaps you live in Norway or Sweden or something. They're not figuring it out, so it's up to us. So, for those of us that like to grow things, it's sort of like, okay, we'll hold down this part. Like I want to be a source that people can come to for the melons that work for here down in the future, without, the cucumber beetles just don't eat, or the ones that don't get sun scald, or the gophers don't come up and eat them from underneath, or just whatever, or that can compete with the weeds, or so understanding plant breeding is you're getting into fine-tuning the, how can we influence this? And I think, for myself, my deepest teachings around all this have come from just being out and observing nature. And sometimes when we, as humans, try and reconcile our differences, and we get into semantics around religion or dogma or, scientific practices, and a lot of the way we adhere to these rigid ideas sounds a lot like dogma to somebody that doesn't, prescribe to our particular point of view. But if we go back far enough, all the spiritual teachings, where do they come from? They come from nature. If you want to learn about the wind, I could tell you all about the wind. Somebody else could tell you about the wind. Go climb a tree in a windstorm. You'll learn something about the wind. You want to understand about water, go sit in the river, or go be in the ocean. Or you want to understand, about the soil, go dig, go be in it, interact with it. And then what is, appropriate and germane to you will come into you and become your wisdom that you can carry forth. And so, for me, spending time, we're really blessed here in Oregon to have a lot of wild nature around. And, there's an incredible blueprint there for how to go about doing all this stuff. So here's an old aerial view of our home farm. A lot of water catchment. And for me, I joke at the irony of, we have a seed company. So it's in my best interest for everybody's land to be in growing weedy annuals in arrested succession. And that's sort of like a permaculture diss on vegetable gardening. But I also want everybody to perennialize their landscape as quickly as possible, so we don't need to be tilling the soil and destroying the microorganisms in the soil that make the whole thing possible. Because when you till, you all of a sudden have to do all this work to fix what you just screwed up. So, a couple guys in the back earlier, we were talking about, there's this new technique of no-till farming that these people in Pennsylvania are doing that I'm really intrigued with, and especially because it's got a cool name. It's called occultation. And it's using big truck tarps, like those ones that they put on semis. You drag it over a cover crop a few months in advance, and all that rots down. Like, who's left some cardboard out, and then you peel it back and look at the soil and all the worms underneath? Whoa, it's just nature just made a garden bed for you. So how can we do this on scale? Again, like looking at nature. How does nature do these things? A boulder rolls off a cliff, and all of a sudden that little spot is a great spot for things to grow. So how are we allowing our system to become that? So now, like with my seed company, I've realized, oh, it's kind of cool that like tomatoes are the gateway drug into gardening. People try an heirloom tomato. A friend brings it back from the market. Whoa, this is the most amazing thing. Where'd you get that? Oh, I got it at the farmer's market. And then all of a sudden that person goes to the farmer's market, and they're supporting direct, retail sales from the producers. And then eventually they're like, dang, that's expensive. I'm going to grow a garden myself. That can't be that hard. Look at that guy. He's not that smart selling this stuff. I'm going to go do it myself. So then they start a small garden, and they grow some tomatoes, and then maybe they begin to growing some basil and then some zucchini. And then after a little while, they're doing it with their friends and their family, and then they want some strawberries. Whoa, they're in perennials, asparagus, artichokes, and then you want some fruit trees. And the next thing you know, you're like, dang, wouldn't it be cool to harvest your own nut trees? Or have like ducks or chickens. So, for me, I'm having this idea, and this is really where I'm kind of taking off my ecologist hat and getting into the kind of more entrepreneurial side of things, is how is what you're doing transforming the world to be that which you want. So instead of humans, Wes Jackson, one time I heard him speak, and he's like, we shouldn't call people consumers. Wildfire consumes a forest. It doesn't it's not a good way. We are creators. Through our decisions, we create the world that we want to see. So how, as business people, how is our interaction with the marketplace helping to foster the culture that will enable fertile ground for those coming up after us? And so that's what I'm constantly thinking, like, how do we work ourselves out of a job? Because we're going to be bored of this in 10 years. And we want to be doing the next thing. So that's why I was talking about like the variety trials and then the plant breeding. And, so, for myself with a seed company, like I just started offering comfrey cuttings on there, root crowns. And I'm like, well, I know some people are going to like be mad at me in a number of years because it's going to get into their garden and they're not going to be able to get rid of it. But then they'll plant fruit trees there and they'll feed it to the chickens and ducks and they'll realize, wow, that comfrey is really good stuff. Or they'll use it for a wound. And they'll have an awareness about like, oh, wow, yeah, all the diversity in nature is important for all these other needs we have as humans. So it's sort of, in a way, a little subversive. And I kind of like, I think, for those of us that are not totally happy with the way things are going, I think that we need to instill our imagination with a little dash of subversiveness, so that we are helping to transform the culture into what we want it to be. So not so much a parasite, but like a symbiont. And you can think of like the way a lichen is an algae and a fungi working together to break down rocks and minerals to make it available for other things. So really, I think that those should be maybe our totem, what do we call them? Bryophyte? It's not an animal, but to encourage us of where are we headed with all this stuff. And because if we don't, then it won't happen. We can't wait. And I guess I'll kind of close with this this cool image of one of my favorite crops that we get to interact with. This is Bullwhip Kelp. And I don't do this to make money. I like going out in the ocean. It's like the coolest, especially as a farmer, like to go out in this vast thing and there's a whole garden that no one had to plant and it's like, you can harvest all you want. And it transforms you in your soul and the experience that you're having there. So Lao Tzu, who many of you may be familiar with the work, the Tao Te Ching, he later came up with a collection of verses called the Hua Hu Jing after he disappeared from public life and just disappeared in the forest. And one of the verses, just the ending of it, is a very profound statement. I repeat it to myself oftentimes multiple times a day, every day. And it's, what you do is who you are. And you can say all sorts of things. But I know I'm a dad. I have two boys that are 10 and 14. I could tell them all about stuff. I'm really smart. I can run circles with words around them. But what they see is, what do you do? Like you say you don't like that music, but then you dominate the stereo. So like what? And that's, at the end of the day, that's all we have in our life, is what did you do? What everybody else, they're watching what you do. And what you say, what you write, what you say you're going to do is very different than what you do. And I think, this is why the Eastern thought forms are really cool, because they condense it down into this nugget because of it. And that was said, to put this in reference, 4,800 years ago. And it still bears a lot of relevance today. So I guess, I kind of threw a bunch of stuff out there at you. And ultimately, I just want to, encourage us all to keep going on the journey, because it will lead us somewhere good, as long as you are, in alignment with all the other things that are good, and try and somehow make it so that it's a, an expanding, like the way nature is in terms of its diversity and abundance and the proliferation of more good things like you want to have experiencing in your life. So, just figure out, as we, and here's where I'll actually close. And again, this is putting on my entrepreneurial cap. And great book that I had the opportunity of reading recently is called The Third Circle Theory. And the author chose to remain humble, didn't even ascribe his name to it. And it's about, how do you take your business to the point where it's like, who is the CEO of Sony? No one knows. everyone knows who the CEO of Apple was. You know, how to become a person of impact in the world. So from that was a little recipe. Have a vision of where you're going for your life. And then take that vision and you write it down. And once you write it down, it becomes a goal. And then if you take that goal and you list it into steps, like how am I going to actually achieve this goal? Then those steps becomes a plan. And then if you do the plan, it happens, right? So let's go do it.